So now, Rutherford's scattering experiment. Alpha particles were directed toward a very thin gold foil. Rutherford observed that although most of the alpha particles passed through the gold foil, a few were scattered at various angles, as that video showed us before. Some were even scattered back along their original path. It was similar in, to scale as like shooting bullets at a piece of tissue paper and finding them some bounce back from the paper. Like it was kind of weird, okay? So based on these observations, Rutherford concluded that the mass of the atom is not evenly distributed throughout the atom as proposed by Thomson. So Thomson said, okay, the electrons are evenly distributed, but that model doesn't really explain his observations. So then he said instead, he was able to explain his observations if the model was revised to the idea that the mass, the positive part of the atom, is concentrated in a very small region. So when those alpha particles, because the alpha particles are positive, so when they hit the positive, they're going to be bouncing back. Now, it's actually very small, how small the nucleus is. Like we draw these big models, but so say we were to think about like a big house, how big a house is, okay? I don't know, okay, so a big house. I was just about to say that. Think about Hayden's house, okay? It's a nice big house. The size of a nucleus would be a marble inside the house. That's pretty small for the atom to have mostly, like all of its mass in there. So, and the electrons would just be like little, I don't know, what came to mind was little spiders hanging around the house. And so really, it's mostly open space or empty space. So that's interesting. But anyways, there was, blah, 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 a flaw to Rutherford's model. If the positive nucleus is concentrated in the center, what keeps the electrons from being pulled into the nucleus? Because they're negative, the nucleus is positive, why doesn't it just implode? Due to the electrostatic attraction, okay? Why not? So what was developed was the planetary / nuclear model of the atom was proposed and explained that if the electrons were orbiting the nucleus like planets, the electrons would stay in their circular orbit. However, so this is like the planetary model that you see in cartoons and things, atoms, But this is also a problem because an accelerating charged particle, according to quantum mechanics, will emit EMR. So those electrons orbiting around are emitting EMR. Well, if you emit EMR, electrons are emitting energy. EMR is energy. And it will lose its kinetic energy and spiral into the nucleus, exploding the atom. Anyways, so this is invalid, or it's not like can't be accurate because the electrons emits EMR as it moves in circular path which means it's accelerating and loses energy.
Who proposed that model?
Rutherford. Oh, I don't know. Because it's not Rutherford's model, is it?
No, that's the top one.
Let's look it up.
It's Hindenburg.
Heisenberg?
Heisenberg.
Was that him? Let's check it out.
Heisenberg. Heisenberg. Breaking Bad. I know who Heisenberg is.
You're just so cousin. What if his
You're
last
in
name
a-
was Heisenberg?
You're in a bad mood today.
You know what? It is Rutherford's model.
He has two.
What do you mean, two?
This one up here.
No, that's Thomson's. He's saying that that's why that's not valid. That's so like this is kind of this is kind of like a okay. It must that's like simplistically it must be positive in the middle. Okay, and then he developed this from like his ideas of that. Yeah, good idea. Good question. Okay, so the model